Next is 11.6, solving quadratic equations by factoring. This is the first of two sections whose essential premise is we've spent all this time learning about factoring. Why? Let's learn some things that factoring can do for us. So now we're ready to use our factoring to solve quadratic equations. So what's a quadratic equation? We've been dealing with quadratic polynomials, which are just polynomials of degree 2. So a quadratic equation is just one of those with an equal sign, right? Something that can be written as ax squared plus bx plus c equals 0. Doesn't always look like that when it's handed to you. You sometimes, and we'll look at some examples, have to do things to make it look like that. But we can. Let's look at an example. X squared plus 7x equals negative 12. That is not of the form ax squared plus bx plus c equals 0. But certainly we can make it of that form. All we have to do is move this minus 12 over there. So I'm going to add 12 to both sides. If I add 12 to both sides of this equation, I'll have x squared plus 7x plus 12 equals 0. I added 12 to both sides. Now it's in the right form. Now, I don't know how to solve this equation. We haven't gotten there yet. But I know that the title of the section is Solving Quadratic Equations by Factoring, so I'm going to assume I'm going to have to factor it. So I have this polynomial, x squared plus 7x plus 12 equals 0. X squared plus 7x plus 12. I now want to factor it. I think, what two numbers can I multiply and get 12 that add up to 7? 3 and 4. So I'll just factor that as x plus 3, x plus 4, still equal to 0. Still the same equation. I haven't really done anything. Certainly I haven't solved it. To solve it, I need one more thing. Something called the zero factor property. This is something that you've seen all the time with numbers previously. If I have two numbers, I multiply them and I get 0. Certainly one of them was 0. Possibly both were 0. But you never have like 5 times 7 equals 0. That's never going to be true. But 5 times 0 is 0. Yeah. If I have two things, I multiply them and get 0, then one of them was 0. So now let's look back at that equation that we just got from factoring. X plus 4 times x plus 3 equals 0. That means I have either x plus 4 equals 0 or x plus 3 equals 0. Now I can solve for x. X plus 4 equals 0. If I want to get the x by itself, I need to move the plus 4 to the other side. So I'll subtract 4 from both sides. X equals negative 4. Same here. X plus 3 equals 0. I need to move the plus 3 to the other side, so I'll subtract 3 from both sides. X equals negative 3. Now I've solved my equation. I have my two possible values of x that make this equation true. Whenever you solve an equation, you should check and make sure they work. Let's plug x equals negative 4 into our equation. I'll have negative 4 plus 4 times negative 4 plus 3 equals 0. Negative 4 plus 4, that's 0. Negative 4 plus 3 is negative 1. 0 times negative 1 is 0. So I'm good. The same thing happens when I plug in negative 3. Negative 3 plus 3 is 0. So my equation is true. So x is equal to negative 3 or negative 4. I have solved my quadratic equation. That wasn't too bad. Certainly there are a bunch of ways that this can get a little bit more tricky. Let's look at a couple more examples. Here's an interesting one. It's also not in a form that I like, right? I never want to try and solve a quadratic equation that has fractions in it. Makes me very unhappy. But since this is an equation, I can multiply it by whatever I want to, so long as I multiply all parts of it by that thing. So I'm going to take this whole equation and multiply it by 8. That means I have to multiply every term in the equation by 8. X squared times 8 divided by 8. The 8's cancel. That's just x squared. X times 8. 8x. 3 times 8 divided by 2. That's 3 times 4. That's 12. 0 times 8. 0 times anything is 0. So this is the same equation, but now it's way easier for me because I did a first step of get rid of the fractions. We will talk a lot more about that method of getting rid of fractions later when we're dealing with rational expressions. Now I can factor this. I think to myself, what two numbers can I multiply and get 12 that add up to 8? That'll be 6 and 2. X plus 6, x plus 2. So I have either x plus 6 equals 0 or x plus 2 equals 0. So x is equal to -6 or -2. Again, I will then take those numbers, plug them back into my equation, make sure it works. You can do that. Or you can just trust me. Those two both work. Let's do one more example for good measure. This is an interesting one. Because if I look at it, I see that cube. That doesn't mean that I can't use my techniques to solve this. Just means I have to be a little bit careful. First, let's just move everything over to the left-hand side of the equation. 3x cubed plus 2x squared minus 8x equals 0. I'm going to look at that left-hand side of the equation, and I'm going to think the first thing I'm always supposed to do is try GCD. Certainly, these have a common factor. Their common factor is x. So I'm pulling x out of each term. X times 3x squared plus 2x minus 8 equals 0. Now, the inside of that is a quadratic polynomial. So let's do our factoring again. I compute AC. -8 times 3 is -24. I'm looking for two things that I can multiply and get -24 that add up to 2. Well, 6 times 4 is 24, right? Yes, that's true. 6 times 4 is 24. So if I had -4 and +6, that would work, right? X times 3x squared plus 6x minus 4x minus 8. Legit. I'll factor by groupings on the inside. Putting in a little extra plus there to make sure I don't have any errors. I'm leaving this x on the outside. When I look for my GCD on the inside here, I have 3x times x plus 2. Here I just have -4, x plus 2. Perfect, that went great. Now we're going to have to go to the next page. I have x times x plus 2 times 3x minus 4. Okay. My zero factor property applies here too. I have three things multiplied together and getting 0. One of them's got to be 0. So I have three options here. x is 0, x plus 2 is 0, 3x minus 4 is 0. Those are my three choices. In all of those cases, I can solve for x. This one's already solved for x. So I'll leave that one. Here, x is negative 2. Subtract 2 from both sides. Here, I'll add 4 to both sides to get 3x equals 4. Then I'll divide both sides by 3. X is 4/3. So I have 3 solutions. X equals minus 2, 0, 4/3. I should always expect to have a number of solutions that's equal to my highest power. I won't always have that many, but that's just because sometimes there are duplicates. We'll talk a little bit more about that near the end of the semester. But normally, if I have something that has x to the 3rd power in it, I expect 3 solutions. And in this case, I have them. I can plug these 3 into my equation, make sure they all work. That is always a good check to make sure that it's gone right. Cool. We have some techniques for solving quadratic equations, and they're the same techniques we've been building this whole time. We just now have a new way of applying them to equation solving.